All right, now that we've kind of finished looking at those experimental designs, I want to give a few warnings or things to watch out for as you're either reading or doing research. So the first one is lurking variables, and we've touched on lurking variables before. So a lurking variable is an explanatory variable that was not considered in the study, but it affects the value of the response variable. It also typically influences the explanatory variables considered in the study. So this is not something you're going to see listed in the research, but it is something that's affecting how things are working out in the relationships you're seeing. So our classic example here, as ice cream sales increase, shark attacks increase. So should we conclude that it's dangerous to eat ice cream before you go swimming? The answer to that is no, and that's because we know there's a lurking variable there, and that's the temperature. As it gets hotter, it's going to influence that explanatory variable, the amount of ice cream people are eating. And it also influences the response variable. So more people swimming means there's a more chance of a shark attack happening. So that lurking variable is something that's kind of skulking around in the shadows. It's not listed, it's not there, but it is causing some issues with your research. All right, so the new one we're going to introduce is a confounding variable. So this occurs when the effects of two or more explanatory variables are not separated or cannot be separated. So they're both influencing the response variable, and it's hard to tell, are they equally influencing it? Is one influencing it more than the other, or vice versa? So it's just kind of a whole tangled mess. All right, so let's look at a couple of examples. A movie theater's special promotion may increase ticket sales, but the marketing folks cannot be sure that's what increased the sales. Or if the weather was particularly bad during the trial period, the people were looking for a cool place to get out of the heat and humidity, and so they went to the theater because that sounded nice and cool. So here, based on this synopsis of the research, the issue we have is that any actual effect of the special promotion is going to be confounded by the weather. So that weather would be a confounding variable there. All right, another example, a study looks at whether radon gas causes lung cancer by comparing the lung cancer rate in Colorado, which is known to have a fairly high radon rate, with Hong Kong, which is much more rare to see that there. Hong Kong also has a much higher smoking rate. So if that's the synopsis we're given there, they're telling us that, well, we think radon's an issue, but oh, by the way, there's also kind of this smoking thing going on, right? So since we know that smoking also causes lung cancer, with the way this is set up, any effect of radon is going to be confounded by the smoking. So if I was going to try and do this and I wanted to try and deal with that, this is a case where I might be able to separate those confounding variables a little bit. And I might look at two places that have similar smoking levels, but then have a low and a high rate on them. Okay, so this one we might be able to separate. Sometimes you can't separate them out. Okay, another example of this might be if someone is dealing with some mental health issues and they go to the counseling center and they do some sort of talk therapy like cognitive behavioral therapy or something like that, as well as they start a prescription of maybe some sort of antidepressants or SSRIs, and they start feeling better 6 months later. Because they're doing both of those, it's a little bit tricky to decide, did both of them really help? Did one help more than the other, or vice versa? So it'd be another example of kind of those confounded or tangled variables together.